Okay, this is a video on rounding, specifically rounding as in rounding correctly and not truncating. You probably remember a little bit of this from grade school, but in case you forgot, here's a flowchart. Look at the digit immediately after the one that you're looking to round, and ask yourself, is that digit a 0, 1, 2, 3, or 4? And if it is, then you don't change the previous number. On the other hand, if it is a 5, 6, 7, 8, or 9, then yes, add 1 to the number. For example, round the number 16.9 to two significant figures. First, ask yourself, does this 9 cause my 6 to round up or stay the same? So, is that digit, in other words, is it the 9, is it a 0, 1, 2, 3, or 4? Obviously no. So therefore, we add 1 to that 6 and our answer becomes 17. Very straightforward. You did this in elementary school. You should be like, oh yeah, I remember how to do this. No worries. Now, here's some practice. There are 6 of them. I want you to do them now. So, please pause the video and do the work. That means there are 6 questions. I want you to do them, not just wait for me to give you the answers. So pause the video, do the work. Okay, hopefully you actually listened to the instructions and you did these, and we are going to go over the solutions here. So 2 sig figs, 21.33, we're looking for only 2 digits. That 3 will not round that 1 up, and therefore it becomes 21. Number 2. 1 sig fig, so we're looking at that 4. Is it going to change the 9? No, so it stays a 9. Third one, looking for 3 sig figs. Is this 4 going to change the 2? No. Oh, but Mr. Lancet, you're going to be like, doesn't that 9 round that 4 to a 5, and then that 5 rounds that 2 to a 3? Shouldn't the answer be 1.93? And the answer is no. When you're looking for 3 sig figs, or however many sig figs, you look at the 4th figure and see what it does to that 3rd figure. So in this case, we're only concerned with what that 4 does to the 2, not whether that 4 becomes a 5, and so forth. Next, 1003.91 to 4 sig figs, that 9 is going to round that 3 up, so it becomes 1004. Problem 5, 5 sig figs, that 1 doesn't change the 9, so it becomes 1003.9. And number 6, 1003.9. Oh man. Okay, so the only way you could get 1003.91 to 3 sig figs is with our special friend, scientific notation. This is kind of the reason why we harp on scientific notation and significant figures together. It's because scientific notation is your friend. Now, to round 1003.91 to 3 sig figs, you can't simply look at the 3 to round the second 0, because then you'd get 1,000, and 1,000 is only 1 sig fig, but if you put a decimal point at the end of it, that gives you 4 sig figs. So there's only one way that you could write this, with 3 sig figs or 2 sig figs, and that is with scientific notation. I have another video on scientific notation and significant figures, which goes into more detail on this, but just bear in mind the first factor, not the power of 10, but the first factor shows you exactly how many significant figures you have. So if you want to write 1,000 to 3 sig figs, it's 1.00 times 10 to the 3rd. Now, measurements. It kind of is important now that we recognize, why do we have significant figures? What is the point? Like, where do they come from? And really it comes from the measurements, because what the numbers actually mean. When I say 10 meters, what does it really mean? Does it mean 10.0 meters? And no, it means exactly what I said, 10 meters. And 10 meters can also be written as 1 times 10 to the 1 meters, as in it only has one significant figure. But what does that really mean? Well, what it means is 10 is actually a range of values between 5 and 14, because 5, 6, 7, 8, or 9 will all round up to 10, and 11, 12, 13, and 14 will all round down to 10, right? So, let's look at this chart. What we really mean is, the more significant figures in your number, the greater the accuracy is in that number, and what that really means is there's a narrower range of values that number could actually be. So if we say 100 with only 1 sig fig, so that's 1 times 10 squared, our range is huge. It's 50 to 140. On the other hand, if we say 1.0 times 10 squared, that's 2 sig figs now, and our range becomes a lot narrower. It becomes 95 to 104. If we say 100 with a decimal point, or 1.00 times 10 squared, that's 3 significant figures, and now our range is even closer, 99.5 to 100.4. So, and so forth. 100.0 is 99.95 to 100.04, and you can see that range gets narrower and narrower and narrower, and it kind of looks like what you see on the side of a hand sanitizer bottle. It says kills 99.999% of whatever, and really that's what we're talking about here, is that range, when we have however many significant figures, tells us our accuracy. Now, back to truncating. Truncating isn't terrible, but it is wrong in this course, and when you look at the chemistry or physics courses, you'll find that the generally accepted method is to round. And if you look up rounding, if you really want to go into the nuance of it, yes, you will find people who argue that, well, rounding isn't exactly true either, because then it skews things, that the 5 should round up half the time, round down half the time, and so forth. There's a lot of details, and you could talk to mathematicians or the math teachers about rounding, but just to keep it within the scope of this course, I want to just let you know that you are expected to round properly, and by properly I mean using the same methods you learned before. Hopefully you learned the correct methods. So maybe I should say round using the method I told you in this video. And that's all. Have a lovely day, and I'll see you in the next video.